Hello everyone, and welcome to this primer video that we have on some more tools that are going to be useful in this class. Um, Specifically, we're going to be looking mostly at some really basic command line tools that you have available. More will be uh, taught about in the class itself. Um, but for right now, we'll still see some useful stuff, especially debugging tools. That's going to be the big part of today. So right now we have this folder here. This is on data. We have a.text, b.text, c.text, and d.text, as well as a C file and a make file for a Fibonacci program. If you want to see how that works, go fib. Let's make it nice here. Fib, and then say 5. Oh, forgot it asked me. There we go. So good stuff. That program works, but we'll still use the debugger to actually go in and inspect it. I have another debugging video that I'll probably post inside this primer as well, but that one doesn't go as in-depth with the actual use of the tool and more into how to use it, or how to go about the process of debugging. This one will be a little more based on what the actual functions of the debugger are. But enough waffling on. Let's take a look at cat. So let's say we want to print out a file. We've worked with like Nano and Vim before, and we can edit files. But what if we just want to print it out and see what's in it without having to go through the process of booting up an editor? Well, easiest way to do that is cat and then the file. So .text, and we have the file printed out. Very good. So cat's a very simple program, but what if we just want part of the file printed out? Maybe we just want to look at the top of the program or the bottom, and that's where head and tail come in. So we can say head 5 a.text, and we'll see not the first 5 lines. We did that wrong. Well, this is a good time to learn how to use man pages. So if you want to learn about how to use something in Unix, do that. Lines, and so that's man pages. We talk about them in the resources video, but always useful to know how to do. So head and 5 e.text, and we get the first 5 lines. And we could do the exact same thing with tail. Here, tail, the last 5 lines. So this could be useful not just in being able to see this stuff, but if you're writing a script. That will be a big part of the systems programming class, but we will not be covering that in this primer series, because that will be mostly in class. Also chmod. So let's actually cat out the make file. Use cat again, and we can see that in the make file we actually have a chmod in there. What this is doing is it's changing the permissions available on the file, so what can be done with the file in each different group. The groups associated with the file are the user, that's the person who owns the file, a larger group, so groups that the file is in, so anyone in that group, in the files group, can have certain permissions. And finally, anybody, and that's going to be any user on the system. So you want to have far fewer permissions usually for people who are for the anybody category than you do for the users category and the group category. In this case, what we're doing is we just want to make this file executable to me, the user who owns the file. So I use chmod U, standing for user, plus saying I'm adding something, I'm adding a permission, X, executable. So I'm adding executability to my file for me. All right, so that's good. And you can do this like read and write too. Instead of X, it would be R and W. And there's other ways that you chmod, like you'll see chmod 777 a lot. That's saying maximum permissions to everyone, to the user group, the group, and everyone group. But chmod's good. The other thing we need to look at is how do you tell the difference between what's in one file and what's in the other quickly. Now this is going to be big on testing and testing your programs, because what will often happen is we will give you tests, and the tests will have two different outputs. One of them is what we expect the output to be, what we want you to match, and one is the actual output you're getting. So we can use these kind of simple comparison programs to figure out what we're doing wrong and help with our debugging. The simplest one is diff. So let's take a look at A again. So A is the alphabet, and B is also the alphabet, but we have something missing, B character. You'll actually see that in a moment here. So we can say diff of A.text and B.text. And it's got this interesting little notation. And I don't really like this notation, but this is the simplest possible one. It's understandable that it's going to give you a simple notation. And it's basically saying that at line 2 there was a deletion of one character, that is B. And that's going to be, this arrow here is pointing to the file that we would do that deletion to make it match. So it's pointing left because we're pointing to A then. All right. So, and like you could even do like, take a look at this if you mix these around. Then we're saying an addition, and now we're pointing to B, or to A on this side. We're saying to make B like A, we do an addition to it. But this is a pain to read, and it doesn't always give you the best clear idea of what's going on, so we can instead use vimdiff. You okay there, vimdiff? Yeah, okay, you're fine. So vimdiff will actually show us visually what's going on. In this case, we can see that in our b.text, which is over here, we have a deleted line. And in our a.text, we have this other b here that isn't there. So we can track down these pretty easily. And this is actually open in Vim, so you can then, quit as normal. You can figure out how to get out of Vim. There we go. So let's try with A and C. So now we haven't seen C before, but we can see here that the difference with C is we have a few letters missing, but the lines are not missing because we don't have that like dashed line going down the middle. These are just empty spaces. So vimdiff can be really good to see exactly what's going on, especially if these files are huge. Obviously, it's easy with the alphabet, but what if you have a massive output file, which first project you probably will at times, and you want to see exactly where something's going wrong? Vimdiff is great for that. There we go. GDB, sort of debugging in general. So these tools here have been very good for some basic debugging, but also just moving around and seeing our files. How do we actually use a debugger? Well, let's open GDB up on our guy there, the fib. So, first note. In fact, I'll put out of here to show you this. We'll cat out this again. I mentioned this in some other video. These are all shot out of order, but I mentioned this in another video. But this -G flag is vital to have if we want to use a debugger, which is pretty much always. You're always going to want to use a debugger. It just loads the symbol table into the actual file so we can use the debugger to move around the source code. So yeah, make sure that's in there, otherwise GDB is going to freak out. But back to running GDB. So right now GDB is stopped, it is not running. Now you'll notice right away we can't see our code. That's why you usually are going to have a frame of your code up on the side, and you can follow along there. But let's say we're going to break at line 5. So there's a lot of commands we'll look at. We'll look at next, step, break, continue. But one thing to note in GDB is it's really a big fan of the just using a letter instead of the whole word. So break is the same thing as just typing B5. See, we set a breakpoint at line 5. Next is N, step is S, run is just going to be typing R, so for here, run. So now we're running. It's also worth noting we can do this list, so we can see what's going on here. We now know that we're at line 5 of this program, or I think, did it take us to line 6 right away? Oh no, it actually did to line 5. Yeah. And now we can start moving through this program. There's 2 main ways to move forward in GDB, and that is next and step. Next is going to go to the next line in the code. So if you're here, it'll go to here. And step will actually do the same thing. The difference is, if you type step, it's going to go into every function. So if you have a function call, it's going to try going into the function and following along with it. While next is just going to skip over the function and go right to the results. So that's the important difference there. I don't know if we even call a function in this one, but yeah, it's not that difficult to figure out its step. But yeah, the break, if you don't know what that is, that's a little point where we're going to stop our execution and let us pull up this little console to do commands. You're usually going to put a breakpoint right before whenever you have an issue, but sometimes if you don't know where your issue is, you'll just put it near the beginning of the code and step through the whole thing. Also worth noting, if you have arguments to your code, so if you're looking for input, like if you have to put a few arguments into your code, those arguments should not go in when you're typing in GDB. So like here, I did GDB fib. If fib took a number here instead of like asking for it with the standard input, I wouldn't go GDB fib 5. I would go run 5. Your arguments are going to go in when you call run. You can also delete breakpoints. That's worth noting. This can be useful if you're in the middle of running something and you kind of rule out a section of your code as being the problem and you're in a loop and you don't want to end up going back there. You could just delete the breakpoint. Quits GDB. But let's keep looking at this moving through the code part. So we can type next. You'll notice I didn't actually type next there, but it still went forward one. If you enter a blank line in the GDB, it will assume you mean to do the last command again. For example, list, new line, list again. It's going forward because list is going to remember how many times you've called it and move through the whole program. So there, we can actually see the whole program that way. But we can keep nexting, printf how many terms, scanf, yeah, now it'll ask, and I'll say 3. Next. Now let's get to print. So print is just going to print whatever data we want it to. There's all sorts of different print options you have. I'm not going to include them here because you can look them up. They're not that difficult to find. But there'll be the stuff like you want to print it in hexadecimal. You want to print it as if it's a pointer, as if it's a string. There's so many options for print. It's a very powerful tool. But we can use it for things like this. Print I, and we'll see that the variable I is currently 0. Print T1, print T2. So we can see the variable values from this. Before we move too much forward though, actually one more thing before we do that, there's also continue. It's either just going to be C, or you can, if you want to be verbose about it, continue. And that's going to move ahead to the next breakpoint. So let's say I want to skip through this whole loop, but I don't want to do the return yet. I can say break 24. We now have a breakpoint right there. And I'm going to continue. And now we're at 24. We've gone past the whole loop. So that's good. Continue is a really useful thing for speeding through parts of your code, especially if you, in this class, we do a lot of like loops that'll go on for hundreds and hundreds of iterations. So it's not worth dealing with it personally. Like you just continue through it. You don't need to next through all that nonsense. But yeah, that's the basic GDB stuff. But we have some other options than just GDB. Yes. The main one, and this is the one I'll actually suggest, the most sophisticated one I won't suggest, honestly, because it's kind of a pain. It's got really cool features, and I'd suggest trying it, but I probably wouldn't suggest using it. The best version we can use, though, is GDB with this TUI flag. This is great because it gives us a little window where we can see what's going on in our code, so we don't have to do list all the time. So I'll go run. Again, if I had arguments, I could go 1, 2, 3, right there. What's it angry about? What did I type? Oh, I didn't give it a file. That would do it. Okay, there we go. Do a breakpoint. Let's put a breakpoint at line 14. B14. We run. How many terms? 4. We're now at a breakpoint. And you see now we can follow this along in a lot more depth. It glitches out sometimes, but that's okay. We can do any prints we want. Our longness, like what's T3 at the moment? T3 is 3. Nice. So yeah, this addition makes things a little easier on us. I do also want to note this will work fine for GDB or 2E, and I think DDD as well. Let's say you have multiple files in your project, which again, you will have that many times in this class. And you want to be able to say what specific file you want to be looking at. Well, we can do that by specifying the file name when we do our breakpoint. So let's go. Sure, we'll run this again. I only have one file in this project, but that's okay. So let's say I want to do fib.c. I know it's going to be in this file. And then I can say the line number like we were doing, or actually the function name is fine too. So if I do fib.c and then I go main, there we go. We now have a breakpoint up there at the start of main. That is going to be invaluable. And again, that works just fine with a number too. So if you do fib.c, and when you're doing that file name, make sure that you're using the source file. You're not doing it from the compiled files. Line 19. So there we go. The last kind of GDB variant that we can work with, this one you'll either have to be in a lab in Lawson, like on an actual Linux machine there, or you can do this if you have something like xming installed. So I've got that running right there. And this is DDD. So DDD is the fully graphical version of GDB. And it's got some interesting capabilities. Problem is, and one of the reasons I don't suggest it very much, is this is going to take an incredibly long time to actually get started because it's going over a network and my network's not very good, and yeah, so we're going to wait for it just to be able to see it. The nice thing with this, though, it has a really cool graphing feature, and that graphing feature works really well with pointers. So we can actually, for like a linked list or something, go through and map out the linked list in a visual medium so we can see what all the pointers are pointing to, and it's really neat. I don't really use it anymore, but it's cool. I don't know why it's putting an R at the end of these. I think it's just a line break that it's decided. Oh, you know what it probably is? It's probably it probably doesn't get the Windows file. That's probably the Windows line ending. Yeah, that'll happen. Anyways, where's my little, there it is. So we get this. This window's kind of broken. But that's okay, I guess. So we can run. And you see, this is just GDB down here that's running. How many terms? 4. Good stuff. Maybe we can set a breakpoint. We'll put a breakpoint. So much lag. There we go. So we can set a breakpoint, get a little stop sign. We can also do things like display T3. We haven't gotten there yet, so I guess that won't work. That's okay. So we're there. Let's go next. Yeah, T3's been made now, so we can go display T3. See, it says graph T3, and we have that. So the value of T3 right now is 32,767. But now it's going to keep track of that for us. So, so we don't have to like worry about continually printing it. See, now it's 1. Now it's 2. So that's really useful. And again, you can do this with like pointers too. I don't have any pointers in this program to my knowledge. But you can do that with pointers, and then you can like click on them to make it this graph expand. The real use of this DDD is the graph feature. This thing's awesome. That being said, I don't know if I recommend it because you've seen how slow it is, at least on my computer. It will probably be pretty slow on yours too. Give it a try though, maybe it isn't. And if you're in the Lawson labs, why not? It's a more comfortable debugging experience, and from what I've seen. So we can quit out of that. And that's the basic debugging, but I wanted to cover a few more things you can do with GDB to kind of bring you to the next level. And some of these are directly useful in the course. First of all, let's open this again, run. No process in. Oh, it just doesn't want me to press enter. Okay, fine. So let's say you use fork. Let's say you are splitting processes. The default, I'm pretty sure, is to follow the parent. So what will happen is the child process will just kind of spin out and go do its own thing. And the parent will wait at whatever breakpoint it's at or whatever. But we want GDB to follow the child sometimes. If we want to debug, if we want to see if there's something wrong in the child path instead of the parent path. So the way we can do this is say before we could do this as we're running too, but usually best to do it before you even run. Set follow fork mode child. So we do that, it'll make it follow the child. If we do the same thing, but we say parent, it will follow the parent. And this is only after we're doing a fork. We're doing a fork call to have multiple processes running. Another thing that's useful, this is kind of a cool one that not many people know about for some reason. You can conditionally break. So what do I mean by that? Let's say I'm going to set a breakpoint at line 19 if T3 equals 3. So now there's a breakpoint there, but if we continue, oh, we didn't run it. We got to a breakpoint, and we can print, and we say print T3, and we're now at the point where T3 equals 3, which doesn't happen until a few runs through. So like if we print I, we can see, yeah, I equals 3 as well. So this is good. This is good. We can, and it doesn't need to be as simple as like a variable equals something. It can be a proper conditional statement. But this can be really useful for tracking down exactly the bug you're looking for, especially if you know that the bug is going to do something weird, like a value is going to get particularly big for some reason and it'll get into a garbage value. You can say, all right, if it's not in this range, I want it to be a breakpoint. So it can kind of alert you to when something's gone wrong, exactly when it starts going wrong. The other thing is record. I probably wouldn't mess with record because it doesn't always work very well. So what record will do is it will slow down the process by memorizing every single machine code instruction that goes through the computer, which is useful because that means we can actually reverse. We can go backwards in the code. Problem with this is it doesn't seem to like certain calls, including, I think, system calls, and I think that means printf fails. So if you're doing any printing in there, it's going to get all angry. Let's rerun. Yes, start from the beginning. I didn't set a breakpoint. Dang it. Got that breakpoint again. All right, breakpoint at 7, and then I'm going to rerun. Yes. So I'm going to, yeah, so I'm at 8 actually, they put me at. And I'm going to say record. So now we're recording. Right now, T1 is garbage data, T2 is garbage data. I go next, and I go next. Now I print T1. T1 is 0, print T2. That's 1, very good. And now I'm going to reverse, so I'll say reverse R next. Reverse next. We go up 1, there's next, we go up 1, it tells me I'm at the end of my reverse history. And we can see for T1, we're back to our garbage data. So that's a really useful thing, but then here's the problem. Next, next, next. We went right into a printf and it decided to die. So I don't know how to fix that. I haven't tried particularly hard, but that's okay. I suggest just don't use record, and if you're doing prints also. If you're just doing like some calculations, then you can probably use record. But yeah. I do have here, these are all in the notes, by the way, so if you can grab them from the repo. But here's a little more in-depth look at how to do record, and that might be able to help you get around some of the more annoying problems. The other thing, I showed you this with how to choose which path you go down with fork, so if it's a different process. But I didn't show you that with threads. This video kind of goes over that real quick. They had a nice setup, and I didn't want to do it. So you can go to this one, and they'll tell you about threads and how to split off into a particular thread, specifically when you're using the pthread library. And I think that's it for the day. So we've covered some interesting topics. This is going to be uber useful on the shell lab and on the web server lab. This is useful all the time. Conditional breaks are great. As far as the different GDB variants, I'd probably use TUI, though it's kind of annoying me right now because it keeps kind of glitching out at different times. I don't know what that's about. DDD is really cool, but a pain because we have to actually have an X client running. And know all of these. These are important commands and will make your life easier, especially vimdiff. Because like the labs, the testing usually defaults to using diff, which is fine, but it's not always the most human readable. So, if you open up in vimdiff, you might understand that a little more clearly. And that's it. Peace.